Hello, welcome back. In this video, we will see arrays. Array is very basic but important data structure. They can be defined as storage containers for similar items placed in contiguous memory location. Let's take an integer variable marks_1 is equal to 63. In a computer, it is stored in a binary format. An integer takes up 4 bytes. Suppose my variable is stored at location 5000, which is memory address. The integer variable will store its 32 bits in 4 bytes. Note that 8 bits equal to 1 bytes. Therefore, these 32 bits will store in 4 bytes occupying addresses 5000, 5001, 5002 and 5003. Now let's move on to the concept of array. As for definition, arrays are the series of containers for similar items. Similar items means all the value will be of same type, such as all integers or all characters. So we can have array of integer or an array of characters. These similar items are stored in contiguous memory location. For instance, if we have 10 integers, each value will take 4 bytes. Though they are stored in a binary format, for readability, I will refer to their decimal values. These are the indexes. In computer programming, indexing starts from 0. So, our 0th element is 63. The first index is 91. And the last item, which is at 9th index, is 48. These are memory addresses. The first number is stored at address 8000. The second at 8004 and so on. Since each integer takes up 4 bytes, you can see that these 10 numbers are stored contiguously. When we declare an array of size 10, it reserves these 10 blocks. If I want to add a number at the 11th position, it won't be allowed because memory after 8039 might be taken by another program. Therefore, we have to decide the size beforehand. Let's discuss the time complexity when using arrays in our code. This is the base address. If I want to print the 0th element, I can print the value present at address 8000. Then, if I want to print the next element, that is at index 1, I can calculate it using the formula address of ith element is equal to base address plus index into size of the data type. Here we are dealing with integers, so it is 4 bytes. If it were float, we would multiply by 8 bytes. So let's see the examples. For 0th index, the address is 8000. For first index, the address is 8000 plus 1 into 4, that is 8004. For second index, the address is 8000 plus 2 into 4, 8, that is 8008. For the fifth index, the address is 8000 plus 5 into 4, 20. So the address is 8020. And for the ninth index, the address is 8000 plus 9 into 4, which is 36. So the address is 8036. The time complexity of lookup by index is O of 1 since it takes constant time. We only need to calculate the address using this formula and print the element at that address. So lookup in an array is very fast. However, time complexity of searching for the number in an array is O of n. To find a number, we may need to go through each element, especially if the number is at the end. As big O notation tells the worst case scenario, here we are considering the number which we are searching is at the end or it does not exist in array and the array is not sorted. So time complexity of search is O of n. The time complexity of push operation, which is inserting an element at the end or any given index, is O of 1. Because we just wanted to insert the element of that particular address and from the formula we can find the address easily. So it's O of 1. It is a constant time. If we want to delete an element, say the second element, all subsequent elements need to shift to the previous address. Therefore, delete operation is O of n. Generally, we don't perform any deletes and insert operations in the array. Now let's summarize. Lookup, push and pop operations are very fast in the array, while searching is relatively slow. Arrays does not require additional space to store metadata, unlike linked list, which we will discuss later. Arrays have fixed size. Once you define the array, you cannot extend it. Okay, so there are two types of arrays. Static arrays, which we just saw, and dynamic arrays. A dynamic array can grow or shrink. When the array size increases, the original array is copied and reallocated with additional size. In Python, there is a library called array, which implements the dynamic array. However, I want to explain static arrays. So for this exercise, I will demonstrate static arrays in C language. In this code, we first define the array size, then assign 10 elements. We can access any elements by its index and also update value by its index. In Python, arrays are not used much. Lists are widely used. But note that lists are not same as array. List can grow in Python, but arrays are fixed in size. Also, we can add different types of data in a single list, such as integer and floats in one list. But in array, the data type should be same throughout the array. We will cover Python list in future video when we learn about linked list. Keep watching the series. Subscribe to my channel if you haven't already. Like this video and see you in the next one.